ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Today we are going to observe session 4 of the unit 6, that is communication and design of mechatronics systems. In the previous session, the various objectives we have learnt were open system interconnections, communication model. ಅದರಲ್ಲಿ ಎರಡು ಕಮ್ಯುನಿಕೇಷನ್ ಇಂಟರ್ಫೇಸಸ್ ಇತ್ತು. ಮೊದಲನೇದಾಗಿ ಸೀರಿಯಲ್ ಕಮ್ಯುನಿಕೇಷನ್ ಇಂಟರ್ಫೇಸ್, ಎರಡನೇದಾಗಿ ಸೆಂಟ್ರೋನಿಕ್ಸ್ ಪ್ಯಾರಲಲ್ ಇಂಟರ್ಫೇಸಸ್. ಸೀರಿಯಲ್ ಕಮ್ಯುನಿಕೇಷನ್ ಇಂಟರ್ಫೇಸಸ್ ಅಂದ್ರೇನು, ಅದರ ಒಂದು ವಿವಿಧ ಚಿತ್ರಣವನ್ನು, ಮಾಡೆಲನ್ನು ಮತ್ತು ಹಲವಾರು ಡಿವೈಸಸ್ಗಳು ಏನು ಬರುತ್ತೆ ಅದರಲ್ಲಿ ಅದನ್ನು ನಾವು ನೋಡಿದ್ದೀವಿ ಪ್ರಿವಿಯಸ್ ಸೆಷನಲ್ಲಿ. ಅದೇ ಥರವಾಗಿ ಹೌ ದ ಸೆಂಟ್ರೋನಿಕ್ಸ್ ಪ್ಯಾರಲಲ್ ಸಿಸ್ಟಮ್ಸ್ ಈಸ್ ಅರೇಂಜ್ಡ್, ವಾಟ್ ಆರ್ ದ ವೇರಿಯಸ್ ಡಿವೈಸಸ್ which are linked to each other in order to have Centronics parallel model, that also we have learnt in the previous session. Today we will going to observe the various objectives of communication systems. General purpose instrument bus, in short form we will call it as GPIB, personal computer bus, VXI bus, VXI ಬಸ್. ಅಂದರೆ ಇವತ್ತು ನಾವು ಜನರಲ್ ಪರ್ಪಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಬಸ್ ಅಂದ್ರೇನು, ಪರ್ಸನಲ್ ಕಂಪ್ಯೂಟರ್ ಬಸ್ ಅಂದ್ರೇನು, VXI ಬಸ್ ಅಂದ್ರೇನು, I2C ಬಸ್ ಅಂದ್ರೇನು ಅದನ್ನು ನೋಡೋಣ. ಸೊ ಬಸ್ ಅಂದರೆ ಇಟ್ ಈಸ್ ಅ ಡಿವೈಸ್ ವಿಚ್ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕೇಬಲ್ಸ್ ವಿಚ್ ಕ್ಯಾರೀಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ ಸಿಗ್ನಲ್ಸ್. ಅಂದರೆ ವಿದ್ಯುತ್ ಸಂದೇಶಗಳನ್ನು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕೇಬಲಲ್ಲಿ ಸಾಗಿಸ್ತಕ್ಕಂತಹ ಒಂದು ಡಿವೈಸ್ಗೆ ನಾವು ಬಸ್ ಅಂತ ಕರೀಬಹುದು. ಈಗ ಒಂದೊಂದಾಗಿ ನಾವು ನೋಡೋಣ. ಮೊದಲನೇದಾಗಿ ಜನರಲ್ ಪರ್ಪಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಬಸ್, ಇನ್ ಶಾರ್ಟ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ GPIB ಬಸ್. ಜನರಲ್ ಪರ್ಪಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಬಸ್ ಅಂದರೆ ಕಾಮನ್ಲಿ ಯೂಸ್ಡ್ ಫಾರ್ ಅ ಪ್ಯಾರಲಲ್ ಕಮ್ಯುನಿಕೇಷನ್ಸ್ ಇಂಟರ್ಫೇಸಸ್. We know that there are two interfaces of communication, one is a serial and another is a parallel. Usually the GPIB is used in the construction of parallel communication interface. IEEE-488 standard originally developed by Hewlett-Packard to link their computers and instruments. So generally when we write the programs in the computers, that program should be executed with the help of our instruments. So in order to connect the instruments to a required computers, the Hewlett-Packard has developed a general purpose instrument bus, that is IEEE-488. ಅಂದರೆ IEEE-488 ಅನ್ನು Hewlett-Packard ಅವರು ಕಂಪ್ಯೂಟರ್ಸ್ ಮತ್ತು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಗೆ ಲಿಂಕ್ ಮಾಡಲಿಕ್ಕೆ ಡಿವೈಸನ್ನು ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ. ಈಚ್ ಡಿವೈಸಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಬಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಲಿಸ್ನರ್, ಟಾಕರ್ ಆರ್ ಕಂಟ್ರೋಲರ್. ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಡಿವೈಸನ್ನು ಬಸ್ಸಿಗೆ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿರಬೇಕು. ಅದು ಲಿಸ್ನರ್ ಆಗಿರ್ಬೋದು, ಅದು ಟಾಕರ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ ರಿಸೀವರ್ ಆಗಿರ್ಬೋದು, ಇಲ್ಲಾಂದರೆ ಕಂಟ್ರೋಲ್ ಆಗಿರಬಹುದು. ನಮಗೆಲ್ಲ ಗೊತ್ತಿರತಕ್ಕಂಥದ್ದು ಯಾವುದೇ ಒಂದು ಕಮ್ಯುನಿಕೇಷನ್ ಇದ್ದಾಗ ಅಲ್ಲಿ ಇಬ್ಬರು ಬಹಳ ಮುಖ್ಯ. ಒಂದು ಕಮ್ಯುನಿಕೇಟರ್ ಅಥವಾ ಟಾಕರ್, ಆಮೇಲೆ ಲಿಸ್ನರ್, ಸೆಂಡರ್ ಆ್ಯಂಡ್ ರಿಸೀವರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಒಬ್ಬನು ಕೇಳೋನು, ಇನ್ನೊಬ್ಬನು ಮಾತಾಡೋನು ಇರಬೇಕು. ಇವೆರಡರಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಆಗಿರತಕ್ಕಂತಹ ಒಂದು ಕಮ್ಯುನಿಕೇಷನನ್ನು, ಸಿಗ್ನಲ್ಸ್ಗಳಲ್ಲಿ ಏನಾದರೂ ತಪ್ಪುಗಳಾದರೆ, ಎರರ್ಗಳಾದರೆ, ದಟ್ ವಿಲ್ ಬಿ ಟೇಕನ್ ಕೇರ್ ಬೈ ದ ಕಂಟ್ರೋಲರ್. ದಟ್ಸ್ ವಾಟ್ ದ GPIB ಯೂಸ್ವಲಿ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ ದ 3 ಡಿವೈಸಸ್. ಒನ್ ಇಸ್ ಅ ಲಿಸ್ನರ್, ಟಾಕರ್ ಆ್ಯಂಡ್ ಕಂಟ್ರೋಲರ್. Listeners are devices that accept data from the bus. Talkers place data on request. ಅಂದರೆ ಇಲ್ಲಿ ಟಾಕರ್ಸ್ ಅಂದರೆ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನು, ಮೆಸೇಜ್ಗಳನ್ನು ಕಳಿಸ್ಕೊಡ್ತಕ್ಕಂಥವರು. ಲಿಸ್ನರ್ಸ್ ಅಂತಂದರೆ ರಿಸೀವರ್ಸ್ಗಳು. ದಟ್ಸ್ ವಾಟ್ ಲಿಸ್ನರ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಡಿವೈಸಸ್ ದಟ್ ಅಕ್ಸೆಪ್ಟ್ ಡಾಟಾ ಫ್ರಮ್ ದ ಬಸ್. ಆ ವಿದ್ಯುತ್ ಸಂವಹನ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನು ಗಳಿಂದ ಪಡಿತಕ್ಕಂತಹ ಒಂದು ಸಂದೇಶಗಳಿಗೆ ನಾವು ಲಿಸ್ನರ್ಸ್ ಡಿವೈಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದಾದಮೇಲೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನು, ವಿದ್ಯುತ್ ಸಂವಹನಗಳನ್ನು ನಾವು ಬಸ್ಸಲ್ಲಿ ಹಾಕ್ತಕ್ಕಂತಹ ಒಂದು ಡಿವೈಸಸ್ಗಳಿಗೆ ನಾವು ಟಾಕರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಜನರಲ್ ಪರ್ಪಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಬಸ್ ಇನ್ನು ಸ್ವಲ್ಪ ಮುಂದುವರೆದು ನೋಡ್ಬೋದು. ದೇರ್ ಆರ್ 24 ಲೈನ್ಸ್ ವಿತ್ ದ ಇಂಟರ್ಫೇಸ್. ಈ GPIB ಅಲ್ಲಿ 24 ಲೈನ್ಗಳಿರುತ್ತವೆ. 8-bit directional lines to carry data and commands between the various devices connected to the bus. So here 8-bit N2-bit bidirectional lines to carry data and commands between the various devices connected to the bus. What are the various devices that connect to the bus? One is a talker, listener and controller. ಇಲ್ಲಿ ಶಬ್ದಗಳು 8 ಬಿಟ್ ಮಾದರಿಯಲ್ಲಿ 24 ಲೈನ್ಸಲ್ಲಿ ಹರಿದಾಡದಿರುತ್ತವೆ. 5 lines for control and status signal. We know that there are talker, listener and controller. ಇಲ್ಲಿ ಕಂಟ್ರೋಲ್ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನು ಅಥವಾ ಸ್ಟೇಟಸ್ ಸಿಗ್ನಲ್ಸ್ಗಳನ್ನು ಮೇಂಟೈನ್ ಮಾಡಲಿಕ್ಕೆ ಕ್ಯಾರಿ ಮಾಡಲಿಕ್ಕೆ 5 ಲೈನ್ಸನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. 3 lines for ಹ್ಯಾಂಡ್ ಶೇಕಿಂಗ್ ಬಿಟ್ವೀನ್ ಡಿವೈಸಸ್. ಈ ಕಮ್ಯುನಿಕೇಷನನ್ನು ಎಫೆಕ್ಟಿವ್ ಆಗಿ ಕಳಿಸ್ಬೇಕಾಗಿತ್ತಂದರೆ there is some device called hand shaking devices. Then for controlling, for sending signals, we are going to use the 3 lines. That's what 3 lines for hand shaking between the devices. 8 lines are ground return lines. So whenever we supply electricity or electrical signals to any device, then we should require signals to be ground. So ಈಗ 8 ಲೈನ್ಸ್ಗಳನ್ನು 8 lines are going to use for grounding. ಅರ್ಥಿಂಗ್ ಮಾಡೋ ಸಲುವಾಗಿ ನಮಗೆ 8 ಲೈನ್ಸ್ಗಳನ್ನು ಉಪಯೋಗ ಮಾಡ್ತೀವಿ. ಸೊ ದಟ್ ಈಸ್ ಔಟ್ ಆಫ್ 24 lines in the interfaces, 8-bit lines are going to be used for the what you called as to transmit the data between the listeners and talkers. 5 lines for control and status signal, 3 lines for hand shaking between the devices, and the last one 8 lines are ground return lines. So we can observe the GPIB structure here. So which consists of instrument A, able to talk, listen and control. Example, computer. Computer can listen, computer can control itself and computer can talk also. Instrument B, able to talk and to listen. Example, oscilloscope. So it can able to talk, it can able to listen but can't able to control itself. Then instrument C, able to listen, only able to listen, function generator. So here we'll have a bus, ಕೆಳಗೆ ಡಾಟಾವನ್ನು ಕನೆಕ್ಟ್ ಮಾಡ್ತಕ್ಕಂಥ ಬಸ್, ದಟ್ ಈಸ್ ಅ 8-bit bus is there. So general purpose instrument bus, GPIB structure, IEEE-488 Bus Standards. This is GPIB Hardware. ಇದನ್ನು ನಾವು ನೋಡಿದಾಗ ಕಂಪ್ಯೂಟರ್ ಬಸ್, GPIB control board, there is a communication between computer bus and GPIB control board. Then from GPIB control board to GPIB cable, again from GPIB cable to devices like listeners and the talkers. Personal computer bus. It is used to connect the CPU to the input-output ports and other devices. We know that PCs, the buses which are used in the PCs is called as personal computer bus. It is used to connect the CPU to the input-output ports and other devices. Different PC buses are used based on the type of microprocessor. We know that what is a microprocessor? Microprocessor is a device which is used to control all other processes in the systems. Now we'll see what are the different personal computer buses. Let's have PC bus, data transfer in bits, microprocessor. XT computer bus, it transfers 8 bits, IBM PC XT and compatible PCs. AT bus, it transmits 16 bits, which is used by IBM PC with 8028 or 80386 bit. EISA PC bus, it transmits 32 bit, IBM PC with 80386 or 80486 bit. MCAA PC bus, it transmits 16 bit or 32 bit, IBM PC or 1PS2. NU bus, 32 bit or Apple's Macintosh 2. S bus, it transmits 31 bit, Sun Micro systems SPRC stations. Then turbo channel 31-bit stations, it is used for stations 5000 workstations. Then VME 32-bit 6800 microprocessor. Then we will see backplane buses. These are nothing but the PC buses. The PC buses are also called as a backplane buses. It means the board on which connectors are mounted and into which printed circuit boards containing a particular function. Example, memory can be plugged. The backplane provides the data, address and control bus signals to each board. So, what is a backplane? The backplane buses which provides the data required, address required and control required to the particular bus. As we know that there are three types of the buses. One is the data bus which carries the data, and the address bus which carries the particular address where the signal has to send to particular devices, and the control signals are carried in the control buses. So this is the pictorial view of backplane bus. We'll have CPU, memory, graphics, then disk controller. So power supply, when disk controller moves to the graphics, memory and the CPU. To the CPU and the memory we'll have to plug in board. These backplane buses will be supports all the CPU, memory, graphics and disk controller. Now let us discuss about the VXI plane. What is a VXI plane? It is the extension of the VME bus designed by Motorola for the use with 32-bit 68,000 microprocessor based system. Designed for instrumentation applications such as automatic test equipment where higher speed communication are required than the GPIB bus. It provides better synchronization and triggering. The system involves VXI board plugged into mainframe. This is a VXI bus option. We can have different computers. External computer is there, internal computer, and we can observe here the microcontroller also, GPI, VXI, so everything. This is just pictorial view for your references. Now let us move to the I2C bus. Data bus referred as the inter-IC communication bus designed by Philips for the communication between integrated circuits or modules. It allows data and instrumentation to be exchanged between devices by means of just two wires. What are the two wires? One is bidirectional data lines called as SDA. Second one is clock line called as SCL. Now I2C bus has transmitter, receiver, master and slaves. Transmitter means generating the message. So whatever the message is generated is by the transmitter. Receiver receives the message. Whatever the messages we have forwarded, it is received by the receiver. Master, it controls the bus operations. Whatever the bus operations, that is going to control by the master. Then slaves controlled by the master. So transmitter which generates the messages, receiver which receives the messages, master which controls the various messages which carries in the bus, and slaves which were controlled by the masters. This is a pictorial view of I2C bus. SDA, SCL is the master transmitter which is called as a receiver, slave transmitter which is called as also receiver, slave receiver, then slave transmitter and the receiver, which each and individual devices are going to connect to both buses like SDA and SCL. Then how the I2C bus works. Clock lines high, the bus is not busy. If the clock lines are high, shows the high, the bus is not busy. Data line low to high, stop of data transfer. When the data line shows low to high signal, then we can observe that the data transfer is stopped. Clock line, if the clock line is high to low, defines that start of data transfer. data line is stable. What is that? If clock lines is a high, the bus is not busy. Data line is low to high, the data transfer stops. Clock line high to low, it starts the data transfer. Data line is stable. One clock pulse per data bit transferred with no limit on the number of data bytes. After each bytes of data transfer, the receiver acknowledges with a ninth bit. The acknowledged bit. There are two: high level put on the bus by the transmitter, low level by a receiver. So till now we have studied various different types of the buses like general purpose bus, I2C bus, no bus, etc. we have seen. Now let us have some of the multiple choice questions of our understanding of the today's session. Question number 1. The PCI follows a set of standards primarily used in PCs. Option A Intel, option B Motorola, option C IBM, option D Sun. Question number 2. The dash is the bus used in Macintosh PCs, personal computers. No bus, EISA, PCI, none of the above mentioned. Question number 3. The key feature of the PCI bus is dash. Option A, low cost connectivity. Option B, plug and play capability. Option C, expansion of bandwidth. Option D, none of the mentioned. Question number 4. PCI stands for Peripheral Component Interconnect. Option B, Peripheral Computer Internet. Option C, Processor Computer Interconnect. Option D, Processor Cable Interconnect. Question number 5. PCI stands for, again the same questions. Question number 6. Address space gives the PCI its plug and plays capability. Question 6 is dash is the address space gives the PCI its plug and plays capability. A. Configuration. B. Input output devices. C. Memory. D is all of the mentioned. Question number 7. Dash provides a separate physical connection to the memory. Question number 7. What is that? Dash provides a separate physical connection to the memory. So memory should have a separate physical connection. Whether it is option A, PCI bus, option B, PCI interface, option C, PCI bridge, option D, switch circuit. Question number 8. When transferring data over the PCI bus, the master has to hold the address until the completion of the transfer to the slave. What is the question? When transferring data over the PCI bus, the master has to hold the address until the completion of the transfer to the slave. True. Option A is true. Option B is false. Question number 9. The master is also called as dash in PCI terminology. Option A, initiator. Option B, commander. Option C, chief. Option D, starter. What is the question? The master is also called as dash in PCI terminology. Option A, initiator. Option B, commander. Option C, chief. Option D, starter. Question number 10. Signals whose name end in dash are asserted in the low voltage state. So these are the symbols. Option A, B, C and D. So these are answers with explanation. The answer for question number 1 is C. That says the PCI bus has a closer resemblance to IBM architecture. That's what PCI bus is designed by the IBM. Question number 2, answer A. That is, the new bus is an extension of the processor bus in a Macintosh PCs. Question number 3, answer is B. The PCI bus was the first to introduce plug and play interface for input-output devices. Question number 4, answer is A. That is, the PCI bus is used as an expression for processor bus. Question number 5, answer is D. The PCI bus is mainly built to provide a wide range of connectivity for devices. Question number 6, answer is A. That is, the configuration address space is used to store the details of the connected devices. Whatever the configuration address in the space which will be used to store the details in a connected device. Question number 7, answer is C. The PCI bridge is a circuit that acts as a bridge between bus and the memory. So in order to carry the various signals in the bus, there should be some link or the bridge, that is the PCI bridge. That's what answer is C. Question number 8, answer is B. That is, the address is stored by the slave in a buffer. Okay, we know that slave which obeys the order of the master. Address stored by the slave in a buffer, and hence it is not required by the master to hold it. Not necessary. Master is not, because whatever the signals given by the master, whatever the orders given by the master will be stored by the slave, and slave in turn saves the address in the buffer. Question number 9, answer is A. That is, the master is also called as an initiator in PCI terminology, as it is the one that initiates a data transfer. Question number 10, answer is B. These are some of the references. W. Bolton. The title of the book is Mechatronics, Electronics, Control System in Mechanical and Electrical Engineering. Clayton, G.B. and Winder. The title of the book is Operational Amplifiers. Edwards, J.D. The title of the book is Electrical Machines and Drives. Gray, P.R. The title of the book is Analysis and Design of Analog Integrated Circuits. Bates, M. The title of the book is Microcontrollers. Golton, J. and Werber. The title of the book is Control System Design and Simulation. Bolton, W. The title of the book is Control Engineering. McGraw-Hill. Thank you. This is our team group. Thank you one and all. ಎಲ್ರಿಗೂ ವಂದನೆಗಳು.